Hello everyone, I am Dr. NAVNEET KAUR, Associate Professor in Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. Today I'll be taking lecture on subject signals and systems. The topic of my lecture is signals and its classification. And the subject signals and system is taught in semester 4th of BTech Electronics and Communication. Now, first I'll start with what is a signal. A signal is a function of one or more independent variable, and the signal conveys some information. Now, any signal or function can be written in the expression f bracket t1 comma t2 till tn, where each of the time variable t1 to tn is called an independent variable, because here the function depends on the value of this time, which is independent variable, whereas the function itself is referred to as dependent variable because it depends on the time instant and decides the value according to the given function. Now, the examples of the signals are like a voltage or current in an electronic circuit, the position velocity of any object, the force in a mechanical system, a digital image or a digital video or audio signal, or a stock market index. Likewise, we can have many examples of the signals in our daily life. Now, as I have already discussed, signals are functions of independent variables and they carry information. Now, in our daily life, we come across common types of signals like electrical signals, which are referred as voltages or current signals in a circuit. Then we have acoustic signals, which are also audio speech signals, and video signals, which is an intensity variations in any image. Now, independent variables are the variables on which any signal depends. Now, these independent variables can be continuous. This independent variable can be discrete, or it can be one-dimensional, two-dimensional, or more than two dimensions. If an independent variable is a continuous variable, then the signal is known as continuous time signal. Whereas when the variable is a discrete in nature, the signal is discrete time signal. Similarly, when a variable is one dimension, we call it one-dimensional signal. And if there are 2D variables, then we call it two-dimensional signals and so on. Now, continuous time signal, as I have already told, that if an independent variable, which is shown here as t, is a continuous function of time, then we call this signal xt as continuous time signal. Now here we can see that the signal xt is defined at every instant of time. So this signal is known as continuous time signal. Now, most of the signals in the physical world are continuous time signal, like voltage, current, temperature, velocity, and etc. Now, here we can see the difference between the continuous time and discrete time signal. Now, here we can see that the signal is defined at every instant of time, so it is continuous time signal. Now, if I'll do the sampling of this continuous time signal, sampling means if I'll take samples at fixed instants of this continuous time signal, now in that case, we will get the signal at discrete instants of time. That means if, say, a first sample is taken at t is equal to 0 and the second sample is taken at an interval of ts, then it is at value t is equal to ts. Now the third sample will be taken as t is equal to 2ts, because here the difference between the two samples should be same. So if the interval between these two samples is TS, then the interval between these two samples must also be TS. So the resulting signal will now be discrete time signal, because here the signal is defined at only discrete instance of time. Now, this signal is discrete time analog signal, because here the value of these samples can have amplitude value in any range, or it can have value in the continuous range. Now, if I do quantization and encoding of these samples, the resulting signal will be discrete time digital signal. That means if I will do the quantization, that means I will round off the amplitude value of these samples to the nearest integer value or quantized value. Then in that case, instead of having a value in the continuous range, I'll be having the amplitude of these samples, which will be having fixed values among any of these quantization levels. Now, if I provide a code for all these in quantization levels, then the values of these samples will be encoded into bit combination, which will be made up of 0 or 1 bit. Here we can see if I am having a sample at this instant, if I will round it off to the nearest quantization level, I will get the quantization level here. Now, if the encoded value provided to this level is 0001, then this amplitude value is automatically encoded into bit combination 0001. This is how an analog signal will be converted into the binary signal or digital signal. Now, coming to the classification of the signal, signals can be classified as continuous time and discrete time signal, even and odd signals, periodic and non-periodic signals, deterministic and random signals. Now, first we will see continuous and discrete time signal. I have already discussed in my previous slides what is the difference between continuous and discrete time signal. Now, here I have shown if a signal is defined at every instant of time, then the signal is known as continuous time signal. But if I perform the sampling of this signal, then I'll get the signal value at only discrete instance of time. Then in that case, the signal will be discrete time signal. Now, the example of continuous time signal is, say, voltage, velocity. Whereas if I take daily stock price or temperature of the day at fixed time interval, then it will be represented by discrete time signal. Now, continuous time signal is represented as X dependent on T, whereas discrete time signal is represented as X dependent on N, where N is any integer and it is a function of time. Now, coming to even and odd signal. Now, here we can see that this signal is having property f of minus t is equal to ft. That means if the signal value at right hand side of the y-axis is same as that of the left hand side of the y-axis, then the signal is known as even signal. Whereas here the signal is known as odd signal, where f of minus t is equal to minus f of t. That means the amplitude of the signal on the right hand side of the y-axis is same in magnitude as that on the left side of the y-axis, but it will be opposite in the sign. Here we can see if the values are positive, here the magnitude will be same, but the sign will be negative. Now, coming to periodic and non-periodic signal. Periodic signals are the signals which repeats after a discrete instant of time or a fundamental time period. Now here xt is equal to xt plus t. That means this signal repeats itself after interval capital T, and this t is known as fundamental time period. Here the examples are cos and sine function. Here we can see that cos and sine repeats itself after a period 2 pi. So these two signals are periodic signals with period 2 pi. Now, non-periodic signal is opposite to a periodic signal. That means the pattern is not repeated for non-periodic signal. Like we can say noise signal, sound signal, where the pattern is not uniform. Or we can say exponential signal. So these types of signals are non-periodic signal. Now, if we have sum of two signals, say x1 and x2, and both these signals are periodic signals, and they have fundamental time periods t1 and t2 respectively. Now, if I take sum of these two signals, then this sum y, the signal which is represented by y, will only be periodic if the ratio t1 by t2 is a rational number. That means t1 by t2 is a ratio of two integers. Now, if this property, if this condition is not satisfied, then the signal y will not be a periodic signal. And if the signal is periodic, then in that case, the fundamental period of this signal y will be the LCM of the t1 and t2. LCM means least common multiple. Now, I have already discussed even and odd signal. Even signal, that means x of minus t is equal to xt, which is represented by most commonly used cos t. Cos is an even signal, whereas an odd signal is negative reflected signal, that is x of minus t is equal to minus of xt. The example is xt is equal to sine t. We can see that sine signal is an odd signal. Now, every signal xt is made up of even and odd component. Now, we can find out even and odd component for any signal. Even component is given as sum of xt plus x of minus t divided by 2, whereas odd component is given by xt minus x of minus 2 divided by 2. So here xc is even component of signal and x naught is odd component of any signal. Now, coming to energy and power signal. Now, first we should understand what is energy of a continuous and discrete time signal. Now, total energy of a continuous signal is E is equal to integration over interval t1, t2, xt square dt. And if I'll find out energy of a discrete time signal, here integral is replaced by summation sign. Xt is xn whole square, and we will take summation over a given time period. Now, energy of the signal is represented by this expression as I have discussed in previous slide. Similarly, we can find average power of the signal by a formula limit t tends to infinity 1 upon 2t integral minus t to t xt whole square dt. Here we can take integration over one time period also, that means 0 to t. In that case, the denominator will become t, which is one time period. Similarly, for discrete time signal, the integral will be represented by summation sign, and we will get energy and average power of any signal. Now, as I have given the formula for energy and average power. Now here we can see that in the formula of average power, I have taken integral over one time period, that is minus t by 2 to t by 2. And here in denominator, I have taken only one time period value, which is t. Now any signal which is having finite energy but zero average power is known as an energy signal. Whereas any signal which is having finite average power but infinite energy is said to be a power signal. Now, this is all for the classification of signal. Now, I'll end my lecture. Now in my next lecture, we will do the classification of the signal in detail, and we will do some examples of these signals also. Thank you.